Alright folks, this is the guide to implicit differentiation. You may be watching this on the delta. If you're watching this on the delta, fast forward to later in the video and I'll be going over like more specific delta problems and notes. To begin with, I'm going to start with the classwork for today. In addition, if you watch this video and you find it helpful, you like the video, you want me to make more of these, just communicate that to me. I'm happy to make more of these. If you like these, let me know. I'd also recommend, I got a bunch of colors out. This is a good lesson for at least two colors. So ideally you have two different colors of pen or pencil, that would be ideal. All right, let's get going. So this is the worm from today. I'm going to teach this like I'm teaching the class. And I want you to try, and then and you can like pause the video, do it, try it, and then if you don't get it, you can watch me. Okay, so x minus 4 squared plus y plus 1 squared equals 36 is drawn on the right. Okay, go ahead, read the questions, try it. Okay, we're back. So how is this expression different from other expressions we have learned to derive? Well, it's not a function, for one thing, right? This is not a function, right? Part of the reason it's not a function is because when I draw a vertical line through it, I'm hitting it at 2 points. Also, there's not really a specific input here. It's like an x and a y value is meeting a condition. So it's not like what we've done before. X and y are on the same side. I mean that's huge, right? X, y, same side. Like that's new. Okay, so then it says draw the tangent line or lines at x equals 6. So let's go to the circle. Let's go to 6, right? And we're going to draw the tangent line here. So you can see, kind of hard to draw. Let's see, that's all right. It's not bad. Got a tangent line there. And if you notice, we're going to have one here. We're also going to have one right here. So we actually have two tangent lines at this x equals 6 right here. Right here and right here. We're going to have two different tangent lines. And then it says calculate the derivative at x equals 6. Hint, isolate y first and derive show all steps. So let's get into that. So if I'm going to evaluate this, I'm just going to use a pen because I'm going to need to write kind of small. Okay, well, I want to get y alone, so let's move this x minus 4 squared over to the right. So I'm going to subtract that, x minus 4 squared, and then here x minus 4 squared. So I'm just going to write the new expression down below. I'm going to have y plus 1 squared equals 36 minus quantity x minus 4 squared. Okay, then I'm going to have to square root this, both sides. And that's going to change that. That's going to cancel out the square. So now I'm going to have y plus 1 equals, also there would be a plus or minus here, but I'll leave that out for now. Square root of 36 minus quantity x minus 4 quantity squared. And then the final step would be then subtracting 1 here, right? So when it all comes down to it, you're going to have y equals square root 36 minus quantity x minus 4 squared minus 1. And this isn't even taking the derivative yet. We just wrote the isolated formula. Then you have to take the derivative of that, of which I'm definitely running out of space. Okay, so in the back of this, so this would be the scratch paper portion. So working from here, we're going to take the derivative of this, y prime. I'm going to have to do some chain rule. So this is, if you look at this, this is all like one big power of 1/2, right? Really, this is saying 36 minus quantity x minus 4 quantity squared, all of that to the 1/2, right? So that through through power rule and chain rule, we're going to have 1/2 quantity 36 minus quantity x minus 4 squared to the negative 1/2. Luckily, that negative 1 goes to 0. And then we're going to have to multiply that by the derivative of the inside. The derivative is, okay, that's going to be 0. And then here we're going to have negative 2 quantity x minus 4. Yeah, this is horrible, right? And maybe not the most neat I've ever written. Sorry about that. Um, but the whole point of this kind of exercise is to frustrate you in a way. Like the idea is like this is kind of horrible, right? I mean, like this is bad. This is horrible. And the good news is that you don't have to do this because we learn a new differentiation method, and that's called differentiating implicitly. And that's what the goal of today is, right? We don't really. This is horrible. Let's not do that. Let's find a better way. There's even worse ones than that. So here we go. Calculating the slope at x equals 6 can be time consuming. Um, in this lesson, we will explore a more efficient method to determine dy dx in a situation like this. To understand how this new method works, we will start by looking at d dx x squared and d dx y squared, where y is a function of x. So easy to begin with. What is the derivative of x squared? That's what that's saying. d dx means take the derivative. If that's not clear, let me just like label that. This just means take derivative. Okay, you guys know that. So derivative of x squared, 2x, easy. Wow, this is an easy lesson so far, right? Going well. Okay, well, let's look at y. Well, because y is a function of x, we can write it as y of x, like f of x. So like, you want to think of y as almost f of x. We're gonna, for the sake of that, we're gonna write it as y of x right now. So we consider the derivative of y of x squared. What is the inner function and what is the outer function? Well, on the outside of here, we have a square function. We have like, there's an x squared essentially, right? That's the outer, right? And then on the inside, right here, we have the inner function, which is the y of x, right? Which is the inner, okay? So, okay, we have an inner and outer function. Now let's chain rule it, right? This is something that I've noticed like on the test and just like talking to you guys, that this, you guys hate this. You don't like this. There's something about this that just doesn't feel right because you're dealing with like this y of x in here, and that, I think that's just weird, right? But when we differentiate this with chain rule, what we have is you're gonna have that 2 come down. We're gonna have 2. And I'll do it in blue to like kind of color code it. That y of x in the middle, right? It's gonna stay there. The 2 comes down, differentiating that. And then we're gonna differentiate the y. And the derivative of y is just y prime of x, right? Following? Okay. So that's the answer. 2y of x, y prime of x, because y is a function of x. You can think of it the same thing as if it was f of x squared, right? Or f of x to the third, right? If we had f of x quantity to the third, the derivative of that would be 3 f of x squared times f prime of x, right? That's chain rule. Okay, we don't know, like I don't know what f of x is. F of x is some other function, but it's a function of x, right? X is an input. Okay. Anaya argues that d dx, the derivative of x squared, is also a chain rule problem with the inner function x. Differentiate d dx squared using the chain rule. Do you get a result that is equivalent to your answer in part A? Well, she's not wrong. We can look at this like a chain rule. Let's look at it like a chain rule, for example. Let's look at it. Okay, well, we have this outer function x squared. All right, yes, we have this outer x squared, and then on the inside we have x on like the inside, right? There's a little x in here. This can be the inner function, right? So when we take the derivative, we're going to get 2, right? 2 comes down, and then we have the x. And then we're going to take the derivative of the inside. Well, the derivative of the inside, what's the derivative of x? The derivative of x is just 1, right? The derivative of x is just 1. So it's just 2x times 1, which is 2x. So that's why when we differentiate with respect to x, when we differentiate x with respect to x, we don't encounter this issue, right? Because the derivative of x is 1. But the derivative of y is a function of x, derivative of y is y prime. Okay, this is key, right? And this is basically the foundations of implicit differentiation, which you will then see. The key is whenever you differentiate a y, you differentiate it as normal, but you must multiply it by the derivative of y. Okay, so let's look at examples, and I think now is a really good time to talk about some notation. So notation-wise, I should add this to the notes somewhere, but you're going to see two different symbols. You're going to see this in the delta y prime. You're going to see that all the time. And we know what that means. This means the derivative of y, right? You're also going to see this, and you're going to see me use this in class, dy dx. And both of these, I want to make it clear, they mean the same thing. Okay, they mean the exact same thing. Both of these mean the derivative of y. They both mean that. Okay, so which one do you use? You can choose to use one of these. However, I highly, highly, highly recommend that you choose to use, and I will use always, dy dx, because you will see in these problems that we're going to have, they get messy, they get big, and it can be very difficult to distinguish what is a y prime, what is a y squared, what is a y to the third. It's really hard to see. There's no messing this up. You're going to know we're in a dy dx when you see one. Okay, so just a little heads up for the future there. Let's continue. So let's take some derivatives. Okay, so what's the derivative of 3y to the fifth? Okay, go ahead and try. Okay, you've tried, let's do it. So we got some chain rule here. Let's take the derivative of the outside. I'm going to keep up with my little color coding here. Hopefully that makes sense. We're going to have 15. My inner function is that y, right? Y to the fourth, right? That's just me taking regular old power rule. But because my inside function is a y, I must multiply this by a dy dx, right? Again, if you wanted to, you can put the y prime, but I'm doing with dy dx. I will always do dy dx. Okay, that's it. So what about d dx, the derivative of root y? By the way, this is one that I really think you should memorize, and I'll show you the wrong way to do it. But at the end of the day, like this, the square root comes up so much that, and I see some of you struggle so much with the half exponents. I just think you should memorize it. So again, this is y to the 1/2. So when we take the derivative of y to the 1/2, we get 1/2 y to the negative 1/2 times dy dx. That's it. It's a conversion. So when I talk about memorizing it, what I'm referring to is that I'll do it here with my little notes here. When the derivative of root x is 1 over 2 root x. That is what this right here simplifies to, that 1/2 y to the negative 1/2. That just simplifies to 1 over 2 root x, or 1 over 2 root whatever. So in the case of d dx root y, it would be 1 over 2 root y dy dx. So what is the difference between taking the derivative of an x and derivative of a y? With the derivative of x, you just do it as normal as you've learned. With the derivative of y, you take the derivative as normal as you've learned, but with the addition of this chain rule thing, where at the end, you just multiply by dy dx. That's it. Okay? Hopefully this is going well so far. Let's continue. So let's now I'm going to use some notes. Okay, before we go into like the next practice problem, let's do like a real problem. Let's do some proper notes. So I'm on the notes. I'm on page 4. We're on implicit differentiation. Implicit differentiation helps us differentiate functions in which you cannot solve for y. How do we implicitly differentiate? Let's do an example. Let's differentiate y to the third plus xy minus x squared equals 4. Okay, let's do it. Hey all, just wanted to make a note here that I'm about to make a mistake in the video. When I write this equation, which was originally y cubed plus xy minus x squared equals 4, I write it as a minus. So all the work is good that I do, but just a heads up, change that to a minus so that it makes sense. So let's write it out. We're going to have y to the third minus x y minus x squared equals 4. So when we differentiate implicitly, you just differentiate straight across. Okay. The only thing I'm going to do, guys, is when I'm writing it, I'm going to do it all in black. But whenever I write a dy dx, I'll put that in purple, just like make it pop a little bit and show you. It'll make things a little clearer. So y cubed, we're going to differentiate that just a normal little bit of power rule. It's going to be 3y squared. But again, because it's a y, we must multiply it by a dy dx. Okay? And then we move along. We got this. Now this isn't the easiest first problem to do because we have some multiplication here. We have xy. So we got to differentiate xy. Well, to differentiate xy, you have to use the product rule. You have to use the product rule. I'm going to write it like this. I'm going to put a minus sign here. So I'm just dropping down that minus sign. And then I'm going to put like a parentheses to show the product rule right here. I'm going to do the product rule right here. So this is me differentiating this, just to be super, super clear. This went down right here. This is right here. And now I'm going to do this right here. So the product rule, we should know, lefty right plus righty left. Left is x, right? Left, d right, the derivative of y. Well, if we think about like, it's 1, right? The derivative of x is 1, so there's no rule to do here. There's no y value that stays. We're at the bottom of the function, right? So it's just dy dx. Plus, so lefty right, plus right, which is y, d left is 1. So that's why it's just y. Technically, I'll put the 1 in just so you see it. It's a little 1 there because the derivative of x is 1. Okay, keep going. Minus derivative of x squared is 2x. Derivative of 4 is just 0. Okay, follow me? Following me? We'll get there. Don't worry. So again, just to be super, super clear, this negative is over here, right? This x squared is over here. This 4 is over here. That's what's going on. All right. We're going to simplify this a little bit, make it look a little cleaner. So I'm just going to rewrite it. 3y squared dy dx minus. This is kind of somewhere where I think a lot of mistakes can be made. I'll show you in a second. I'm distributing right now this negative, right? If that's not clear, this negative is being distributed here, and it's also being distributed down here. So it's going to be minus x dy dx, and also minus y minus 2x equals 0. Okay, following me? So now I got rid of my my distribution. Good. Follow me? Okay, we're going to continue. Collect the dy dx on the same side and all the other terms on this side. We're on step 2. So these dy dx terms, these purple terms here, they're staying. They're not going anywhere. They're going to stay right here. We are going to move the negative y and the plus 2x over to the other side. They're going to get moved over. Okay, let's do that. So we're going to say, maybe I'll show like some of my steps in red, maybe in blue. Let's do it in blue. We're going to do plus y. And I think you guys can handle this. I'm going to add two things at the same time. I'm going to add plus y and plus 2x over to the left, and then I'm going to add a plus y and a plus 2x over to the right, right? Whatever you do to the left, you do to the right, okay? So now, I'm going to bring it down. I have 3y squared dy dx minus x dy dx equals y plus 2x, right? Because these cancel, right? I cancel those out. Okay, all right, we're good. So you've got it all on the same side. Great. This is kind of step 2 and step 3 are going to kind of begin to merge right now. So notice how dy dx is a common factor of both this and this. That means I can take it out as a factor, right? So I can do this. I can take it out. So what I'm going to do is going to take dy dx out. And I'm factoring it out. I'm going to put 3y squared minus x in here equals y plus 2x. Follow me? Do you see what happened there? It's kind of like, imagine like, I don't know, imagine like this was like a 5 in both of them, and you just took a 5 out. It's factoring. It's taking out the greatest common factor. This variable or this derivative exists in both of these terms, so I can just move it out to the front and take it out of both of these, right? Look, this times this is this times this is this. Hope that's really clear. I hope that's clear. We're going to move on. We're on the last step now. We're in the home straight. The last thing you got to do is just to get this alone, right? We have some term multiplied by this other term. We're just going to divide by that upper term, 3y squared minus x. And we're going to do the same on the right, 3y squared minus x. And what's going to happen when I do that is it's going to cancel. These are going to cancel, right? That's going to go, that's going to go. And what's left is dy dx equals y plus 2x over 3y squared minus x. Done. That's it. That's a problem. So just to recap that, you have your equation, you differentiate all across, making sure that any y term that you differentiate gets a dy dx multiplied by it. You group all the dy dx terms on the same side, everything else on the other side. You factor out that dy dx, and then you divide to get your dy dx alone. That is the answer. Okay, so we'll leave it there. Let's go back to the practice. And so now you try, right? Now you have a go. Yeah, have a go. So, oh my goodness, folks. I just noticed a little bit of an issue here. I just wrote this completely wrong, and this was actually a minus. It's actually a plus. So that wouldn't change much. I did such a good job showing the work here. That wouldn't change much. That would just make those two pluses. That's okay. You know, don't worry about it. It's actually going to help you here. Because this is is this the same problem? It's not, right? It is not the same problem. It is a little different. Okay, so why don't you try now by yourself, differentiate this. Okay, all right, now I assume you've paused, you've tried it, now I'll do it. Okay, here we go. So I'm going to do it a little faster this time. We have x squared minus xy plus y squared equals 1. We're going to differentiate straight across. We're going to have 2x minus the same thing here. So I'm going to do that minus, but I'm going to make room for my product rule right here. I'm going to keep going for right now, and I'll come back. Plus 2y, that's a dy dx because I'm differentiating a y, and then equals 0. Okay. Then I'll do my little product rule in here. Lefty right plus righty left. Left is x. D right, derivative of y, is just dy dx. There's nothing else there. Plus righty left is just a plus y because derivative of x is 1. Remember, it's not the derivative of negative x, because what I did, this is just what I like to do, is I put that negative there. That saves me from having to mess around with like negative anything. And then I'll distribute the negative now. Okay, so here we go, and I'm going to distribute the negative. I'm going to get 2x minus x dy dx minus y, because I got to distribute that negative here and here, right? That's what's going on in this like simplification step. Y plus 2y dy dx equals 0. Okay, we're going to move all the terms over that are not dy dx. We're going to move the minus 2x, and we're going to add this y. Okay, so we're going to have negative x dy dx plus 2y dy dx equals negative 2x plus y. So just to be clear what I did there, this is a minus 2x plus y, right? Whatever you do to the left, you do to the right. Okay? Then, hey all, so at this point in the video, now is a great time to do some delta practice, like start getting going, start doing some of those level 1, level 2 implicit differentiation problems, and then I will make a second video talking about the more difficult problems.